You know that specific, deep rhythmic thrum an industrial motor creates right before a high-voltage relay decides to violently burn out? That is the sound of my life at Grayson Industrial Solutions. Most people standing on a factory floor just hear deafening noise. I hear a complex symphony of mechanical balance and impending disaster that only a handful of people in North America know how to conduct. My name is Dean Vance. I am 53 years old. I have a spine curved slightly to the left from 30 years of leaning over programmable logic controller racks, diagnostic conduits, and high-pressure hydraulic manifolds. I possess the exact kind of deep legacy expertise that corporate headhunters love to label invaluable right up until they try to lowball you on a contract renewal package. It was a cold Tuesday morning in Dearborn, Michigan. Tuesdays in an automotive metal stamping plant smell like ozone, hot industrial gear oil, and burnt hydraulic fluid. It is a heavy fragrance you cannot purchase at high-end department stores, and frankly, it smells a lot better than the desperate ambition radiating off our new executive management team. I was standing at Station 4 on Production Line 3. Line 3 is my perpetual problem child. It is a 20-year-old robotic welding assembly that likes to drift out of synchronization whenever the relative humidity inside the facility drops below 40%. I feel it directly through the thick soles of my work boots. The floor vibration shifts subtly from a steady waltz to a hesitant stumble. I was carefully tightening an optical sensor bracket a quarter turn when I felt a sudden presence behind me. It was not the heavy tread of a veteran floor operator wearing steel-toed boots. It was the frantic tap dance of expensive Italian loafers that had never stepped on anything grittier than a plush executive suite carpet. I did not bother turning around. "You are standing inside the high-voltage yellow warning boundary," I said over the roar of the press. "Unless you are certified for 480-volt maintenance, you are about 3 inches away from violating federal safety regulations and voiding your life insurance policy. Dean Vance, right?" "The legacy specialist," a voice replied. I turned around slowly. Standing there was Spencer Cole, our newly appointed director of modernization. Spencer was 27 years old and looked like he had been freshly hatched from an Ivy League Master of Business Administration incubator. He had smooth skin, bright teeth, and a tailored suit that cost more than my first pickup truck. He was holding a slick tablet, looking at my Greek-stained coveralls with mild amusement and barely concealed condescension. "Senior Systems Architect and Automation Specialist," I corrected, wiping a smudge of lithium grease onto a red shop rag. "And you must be the new efficiency director corporate sent down to explain why we need to produce twice as many body panels with half the budget." "Spencer," he said, offering a soft hand. I did not take it, holding up my oily socket wrench instead. He pulled his hand back, dabbing his palm against his trousers. "And actually, Dean, it is Director of Modernization. We are initiating a complete strategic pivot." "Pivot," I repeated flatly. "Is that fancy corporate terminology for breaking systems that work perfectly?" He let out a hollow laugh. "That is the problem with legacy mindsets, Dean. You see something not broken. I see massive inefficiency. You spend 40% of your shift performing manual overrides on line 3. That represents wasted bandwidth. We are transitioning to an enterprise cloud model that automates the automation." I stared at him in quiet disbelief. I wanted to explain that line 3 was not just iron and wire, but a delicate ecosystem of thermal expansion variables and custom logic patches evolved over 3 decades. I wanted to explain that my manual overrides compensated for legacy firmware timing conflicts that the original equipment manufacturer stopped supporting when the Bush administration was in office. But I knew he would not hear a single word. "We have an all-hands meeting in 20 minutes in the main conference room," Spencer said, tapping his tablet. "I will be unveiling our new operational roadmap." "I will be there," I replied, "as soon as I ensure Line 3 does not crush the next pallet of sheet metal." He walked away delicately, stepping over a pneumatic airline as if it were a venomous snake. I watched him go, feeling a cold knot tighten in my stomach. I finished tightening the sensor bracket. Line 3 resumed its steady pulse. Thrum, clack, hiss. It was absolute mechanical harmony. I patted the yellow safety cage gently. "Do not worry, old girl," I whispered. "I am not going to let the smooth-talking man ruin you." As I walked toward the administrative wing, I stopped by my personal locker in the engineering bay, tucked deep behind a stack of printed instruction manuals for a controller system. Discontinued 12 years ago was a small black flash drive. It contained a bit-level backup image of the entire facility's custom microkernel architecture that I had compiled over 30 years of night shifts. It held every proprietary subroutine and custom logic patch that kept this aging factory running with 99.8% operational uptime. I picked it up and slipped the drive into my front pants pocket. It felt cool and heavy against my leg, like a loaded instrument of absolute truth. The administrative conference room was air-conditioned down to 68 degrees. Oscar Diaz, our maintenance lead, Lyle Jenkins, our senior electrical technician, and Toby Miller, a junior automation guy, were already seated. Spencer stood before a projector displaying slides filled with buzzwords like synergy, holistic integration, and right-sizing. I walked back to my desk in the engineering bay with my head held high. Sitting down at my workstation, I brought up the master system console. My fingers moved across the mechanical keyboard with effortless muscle memory built from 30 years of configuration work. I initiated a complete backup verification of my personal subroutines, encrypted my custom microkernel documentation, and compiled a clean diagnostic log. I was not committing malicious destruction. I was simply gathering my personal intellectual property and preparing to step aside. Spencer Cole believed he was terminating an outdated employee. He had no idea he was pulling the primary control rods out of an active nuclear reactor. At 2 o'clock that afternoon, I walked into the Executive Human Resources suite. Sitting behind a polished mahogany desk was Spencer Cole alongside Paige Miller, a human resources specialist. Paige looked anxious while Spencer looked like a chess player about to execute checkmate. "Dean," Paige began, her voice hesitant as she slid a thick stack of legal documents across the desk. As part of our strategic workforce reorganization under Title 29 of the United States Code regarding corporate restructuring, we are formally concluding your employment contract. Spencer leaned back, interlocking his fingers. "Nothing personal, Dean. Simple evolution. You are a mechanical carburetor in a world that has shifted to electronic fuel injection." "I see," I said calmly. "So 32 years of maintaining 99.8% operational uptime makes me a carburetor." "Precisely," Spencer said. "You understand the math. Your legacy contract contains accumulated seniority bonuses that represent an unsustainable burden on our modernization budget." Paige cleared her throat. "The separation agreement provides 2 weeks of severance for every 5 years of service, contingent upon your signature on a non-disparagement covenant and immediate surrender of all facility credentials." I scanned the financial figures. The total severance was insulting, barely enough to cover 6 months of modest living expenses. "And what about technical knowledge transfer?" I asked, looking directly at Spencer. "Do you require me to onboard the new automation team?" Spencer let out a dry laugh. "Dean, please. We have hired a certified third-party digital consulting firm. Their engineers hold advanced certifications in enterprise cloud infrastructure. They do not need legacy lore. They do not require someone hovering over their shoulders, explaining how to patch 30-year-old circuits with electrical tape." He stood up, walked over to an industrial paper shredder in the corner, and picked up a manila folder labeled Vance Contract Renewal. He held it up with a smug grin. "This was the proposal your previous plant manager drafted for your extension," Spencer said. "Digitization requires clean breaks, Dean." He fed the folder into the shredder. The machine roared to life, its hardened steel blades chewing the paper into thin strips of confetti with a loud crunch. Spencer watched the paper disappear with obvious satisfaction. If he had shown even a single shred of professional respect, I might have given him a verbal warning. I might have mentioned that the secondary cooling pumps on the main roof array require a manual logic sequence reset after any major electrical voltage dip. I might have warned him that the primary hydraulic press-on, Lawn 4 experiences severe thermal expansion that will blow out main seals if operate above 85% duty cycle without localized microkernel compensation. But as I watched my professional dedication turn into shredded waste, every remaining thread of corporate loyalty vanished completely. I picked up the pen from Page's desk and signed the separation agreement without arguing a single clause. "Thank you," Page whispered, looking visibly relieved. "Dottie badge and keys, please," Spencer demanded. I unclipped my security badge and set it on the desk alongside my heavy brass key ring. The keys to the electrical cages, the server vault, and the maintenance shop. "And any company diagnostic hardware," Spencer added. I pulled my company-issued phone from my pocket and laid it beside the keys. "That is everything," I said calmly. The black flash drive remained safely inside my front pants pocket, resting against my leg like a warm piece of iron. "Security will escort you off the premises immediately," Spencer stated, adjusting his tie. "Standard corporate protocol. Nothing personal." I stood up, my knees popping softly. I looked Spencer dead in the eye. "Good luck with your modernization project, Spencer. The machinery on that floor has a distinct personality. I suggest you learn to respect it." "Machinery is just serialized steel and silicon, Dean," he scoffed. "It executes whatever code we feed it from the cloud." "Yes," I replied with a faint nod. "It certainly does." The walk through the facility to the employee parking lot was completely silent. Toby Miller walked beside me as my assigned security escort, looking deeply uncomfortable. "I am really sorry about this, Dean," Toby muttered softly as we reached the exit doors. "Who is going to reflash the logic boards when the main line trips?" "Spencer Cole is a modernization director, Toby," I said, putting on my sunglasses. "I am sure his cloud server will reflash the boards for him." I reached my truck, a dependable Ford pickup with 200,000 miles on the odometer. Placing my box of personal desktop items into the passenger seat, I climbed inside and started the engine. I pulled my personal smartphone from my jacket pocket. Opened on the screen was a secure diagnostic utility connected to an isolated remote diagnostic gateway I had configured 5 years ago during an emergency plant overhaul. The corporate network administrators had revoked my primary employee credentials, but they had completely overlooked an isolated microkernel service account named Ghost Ander buried inside the legacy lighting array firmware. Why would they find it? They were scanning for high-level user accounts, not low-level firmware architecture. I checked the connection status. Service state, active. Root access, confirmed. The first 24 hours after my departure were deceivingly quiet. A 50-ton industrial flywheel will continue spinning for a considerable time, even after you sever the drive motor. Spencer Cole spent that first day sipping espresso in his corner office, believing he had successfully trimmed operational fat. But mechanical physics does not negotiate with executive hubris. Oscar Diaz filled me in on the exact details later via a private phone call. The collapse began at precisely 8 o'clock on Monday morning. Spencer had gathered his newly contracted cloud implementation team on the primary observation deck above Line 2. Our high-speed robotic chassis welding line, consisting of 8 heavy-duty articulated robotic arms. At 8:15 that morning, Spencer tapped a command on his tablet, severing Line 2's local logic controller loops and routing motor execution logic through a remote enterprise cloud server located hundreds of miles away in Virginia. "Seamless digital transformation," Spencer announced over the floor intercom system. By 10:15 that morning, the microsecond latency drift began. In standard computing, a network delay of 200 milliseconds is unnoticeable. In high-speed heavy manufacturing, where robotic arms swing 500-pound welding heads, at 10 feet per second, 200 milliseconds is the precise difference between a flawless weld and catastrophic destruction. The smooth hum of Line 2 instantly broke into an irregular metallic clatter. The robotic arms began hesitating in mid-air, their optical sensors hunting wildly for synchronization signals arriving late over the cloud network. "Stop the line immediately!" Oscar Diaz shouted, reaching for the manual emergency stop button. Spencer leaned over the catwalk railing, waving his hand frantically. "Do not touch that control. It is an initial algorithmic calibration phase. The cloud neural network is optimizing movement vectors. Allow the system to run." The floor operators stood back in terror. At 10:45, Robotic Arm 4 moved to execute a structural weld on a chassis rail that Arm 2 had not finished positioning due to signal delay. Instead of striking steel, Arm 4 struck empty air, swung wildly out of its envelope, and slammed into the heavy steel safety cage. A massive shower of white-hot welding sparks exploded across Station 3. Automated hardware interlocks triggered instantly, shutting down main drive power with a deafening hydraulic groan. Absolute silence descended across the facility. A heavy silence that cost roughly $850 every single minute. Maintenance team, Spencer bellowed through the intercom. Get line 2 operational immediately. What is wrong with those mechanical arms? He committed the classic rookie mistake, blaming physical hardware when the digital brain was scrambled. Oscar Diaz and Lyle Jenkins rushed onto the line with diagnostic meters. They checked servo motors, verified line voltage, and inspected physical drive belts. Everything was mechanically pristine. The hardware is in perfect condition, boss. Oscar yelled up to Spencer. The logic timing is out of phase. The cloud controller is lagging behind the physical drive shafts. We have to roll back to Dean's localized microkernel loop immediately. We are not rolling back, Spencer shouted, his face turning crimson. The cloud architecture is our corporate standard. Fix the network latency on your shop floor equipment. You cannot fix the speed of light with a pipe wrench. Oscar roared back. Meanwhile, inside the server room, Spencer's cloud consultants were sweating. They attempted to force the cloud software to overwrite Dean's original microkernel partitions, but every wipe command returned a low-level hardware security fault. Error code 4003, operation forbidden, master architect digital signature required. Who holds the root encryption keys? The lead consultant yelled frantically. Nobody in that room held the root keys. I held the root keys, sitting on my wooden porch in Traverse City 300 miles away. Watching the wind ripple across the lake while sipping hot tea, Spencer stormed into the server room, his tie loosened. Why is my primary production line sitting dark? I promised corporate executive leadership a 15% throughput increase by noon today. We are locked out of core hardware registers, the lead consultant stammered. There is an embedded logic kernel operating below the operating system layer. We cannot bypass it without the root authorization code. Then force a complete override, Spencer screamed, slamming his fist onto the server rack. Crack the encryption. If we force a brute force override, we risk completely disabling physical collision protocols, the consultant warned. The entire robotic line could destroy itself. I do not care about your warnings, Spencer yelled. We are losing tens of thousands of dollars every hour. Override the safety protocols and get those arms moving now. Overriding safety protocols on an industrial stamping line is the mechanical equivalent of cutting brake lines on a freight train. Because you think, brake shoes slow down travel time. Back at my cabin, my smartphone vibrated. A red diagnostic alert flashed on the screen. Critical event, safety protocol override initiated by user system NOC-SMAR. Warning, thermal overload protections, disabled on press 6. Warning, collision interlocks bypassed on line 2. I stared at the scrolling text. He actually disabled the physical safety interlocks. With a few taps on my phone, I could have remotely re-engaged the safety locks and saved the company millions. But Spencer had shredded my contract extension on live camera and called 30 years of my life's work redundant garbage. Let the hubris burn, I whispered softly. I closed the app and put my phone away. The mechanical disaster struck at 1:30 that afternoon. Line 2 restarted with a high-pitched electrical whine. Spencer stood on the catwalk with arms folded, attempting to look like a victorious commander. Without low-level microkernel validating physical arm positions, every 4 milliseconds, the robotic arms moved faster than ever. For 90 seconds, it appeared Spencer was an operational genius. By 3 o'clock that afternoon, the initial damage assessment arrived. Robotic arm, 3 primary housing, destroyed at $22,000. Heavy hydraulic clamping assembly, pulverized at $6,000. Contaminated raw material scrap at $14,000. And minimum estimated repair downtime at 48 continuous hours. Then the red emergency telephone mounted on the wall of the plant manager's office began ringing. It was a direct line from corporate headquarters in downtown Detroit. Mr. Alistair Thorne, our corporate chief executive officer, was on the line. Alistair Thorne understood financial balance sheets with ruthless precision. Sitting on his desk was a real-time digital dashboard, tracking active manufacturing output across all regional facilities. That dashboard had just dropped to absolute zero for the Dearborn plant. Why am I looking at a red zero on my primary production board? Alistair. Thorne's voice thundered out of the speakerphone. And why did corporate risk management just receive an automated fire suppression discharge report from Line 2? Spencer Cole stammered violently. Sir, we experienced a minor mechanical hardware anomaly during our scheduled cloud migration. A localized sensor defect. A sensor defect? Thorne interrupted, his voice dropping into an icy tone. We completely replaced every optical sensor array in that plant 6 months ago. Dean Vance presented that capital expenditure project to the board personally and guaranteed those sensors for 5 years. The name echoed through the quiet office like an uncomfortable ghost. Dean Vance well. Dean Vance is no longer associated with this facility, Spencer attempted to deflect. Frankly, sir, his legacy configuration likely masked underlying hardware defects for years. Did his configuration mask defects, or did his expertise actively manage them? Thorne fired back sharply. You assured me this cloud transition would be seamless. You assured me Dean Vance was an obsolete operational redundancy. Right now, that redundancy is costing this enterprise $30,000 an hour in contract non-performance penalties. It is merely a momentary operational hiccup, sir, Spencer pleaded desperately. We will have Line 2 fully restored by the start of the night shift. You had better have it running, Thorne growled, because if we miss our scheduled chassis delivery to the Ford assembly plant on Friday, the board of directors will not be replacing a mechanical sensor. They will be replacing you. The line went dead. Spencer slammed the receiver down, turning furiously toward his lead IT consultant. Fix it right now. Why did the software override fail to prevent that collision? It did not fail, sir, the consultant whispered. The cloud code executed precisely what you instructed it to do. It ignored hardware errors. But according to our kernel diagnostic logs, the system attempted to call a localized subroutine named Safety Curer 4 right before the crash. What is Safety Curer 4? Spencer demanded. It is a low-level microcode file embedded in the physical bus logic, the consultant explained. But the access path was blocked because your team revoked all system permissions for its creator on Friday afternoon. Who created it? D. Vance. The consultant swallowed hard. Spencer stared at the screen, wiping cold sweat from his forehead. Erase it, he spat out. Delete every single reference to Dean Vance from those servers. Build a brand new safety protocol from scratch. Sir, writing a low-level machine safety kernel from scratch requires months of testing, the consultant argued. We cannot write machine code overnight. You have until 6 o'clock tomorrow morning. Spencer screamed. Meanwhile, in Traverse City, I was taking a peaceful afternoon walk along the shore of Grand Traverse Bay. I picked up a flat stone and skipped it across the clear blue water. 1, 2, 3, 4, 5 skips. Not bad for a 53-year-old guy with a bad back. Checking my smartphone remote diagnostic app, I saw error logs cascading across the screen in bright red text. Spencer's IT consultants were making fundamental novice errors, 6 mismatches, circular logic loops, and invalid memory address calls. They were desperately trying to decipher a complex machine language I had spent 30 years perfecting, without possessing the master dictionary. I felt a slight twinge of sympathy. Not for Spencer Cole, but for Oscar Lyle and the guys working mandatory double shifts to clean up hydraulic fluid. But I knew this trial by fire was mandatory. The lesson had to be expensive, absolute, and undeniably clear. By Wednesday morning, the factory resembled a disaster zone. Line 2 was completely ruined. Line 1 was operating at 30% speed because floor operators were terrified that touching controls would cause another collision. Spencer Cole looked like he had aged 15 years in 48 hours, erased the legacy partitions. Spencer ordered his IT crew at 8 o'clock Wednesday morning, execute a complete factory-level hard reset. Lyle Jenkins, our senior electrical technician, stepped forward. Spencer, you do not want to execute a hard reset on this facility. Do not presume to tell me how to manage digital infrastructure. Spencer snapped. A factory hard reset wipes localized flash memory back to 1998 base manufacturing defaults, Lyle explained calmly. It means your modern cloud servers lose physical connection to every motor encoder on the floor. You will lose 30 years of precision calibration data. I do not care about legacy calibration, Spencer yelled out. We have cloud backups, the cloud backups that failed to synchronize due to your network latency issues? Lyle asked dryly. Spencer froze. He was completely trapped by his own hubris. Access the factory reset. Spencer commanded wildly. Burn the legacy partition down to the bedrock. We will rebuild the entire logic architecture from scratch. Sir, that will take the entire plant offline, the IT consultant warned. Everything. Floor lighting, air compressors, main ventilation, security doors. Do it! Spencer shrieked. Wipe Dean Vance out of this system once and for all. The consultant typed the command, format system root. Force. Oshray the system prompted, proceed. Why nah? Then enter. By Thursday morning, the facility had been dark for 24 hours. Financial bleed was staggering. Outside security gates, dozens of heavy semi-trucks were backed up onto the highway, unable to unload raw steel coils because electronic unloading cranes had no power. Supply chain was paralyzed. At 7 o'clock Thursday morning, Spencer Cole committed his final error. Desperate to restore power, before corporate leadership arrived, Spencer hired an uncertified third-party electrical crew to enter the high-voltage master power vault. He ordered them to manually bypass logic controllers and hotwire 480-volt three-phase electrical bus bars directly to main transformers. Oscar Diaz called me from his truck, his voice shaking. Dean, Spencer has lost his mind. He has contractors down in the main power vault trying to bridge main bus bars with copper jumper bars. I sat up straight on my porch. Hot wiring three-phase power? Oscar, if they bridge those bars without verifying phase sequence rotation, the entire 480-volt supply will run in reverse phase. I know, Oscar yelled. Every heavy motor in the plant will run backward. Hydraulic pumps will blow housings. Ventilation fans will pull toxic exhaust fumes back into break rooms, and 300-ton stamping presses will cycle upward, shattering steel, casting dies. Are there workers inside the building? I demanded. The morning maintenance shift is sitting in the cafeteria waiting for power. Oscar reported. My blood ran cold. Bypassing phase sequence protection on a high-voltage industrial supply was an immediate threat to human life under Title 20 life of the Code of Federal Regulation regarding workplace safety. Put Spencer on the phone immediately, I commanded. He smashed his phone when corporate called him an hour ago, Oscar shouted. He is completely insane. I hung up and opened my custom remote diagnostic utility on my smartphone. Years ago, during installation of the main electrical substation, I had installed a dedicated, hard-wired cellular emergency relay directly into the master circuit breaker panel. It operated completely independent of plant servers, power lines, or network infrastructure. It was designed as an ultimate fail-safe, a digital dead-man switch intended to cut main power in the event of a catastrophic fire or grid instability. It responded to a single hard-coded text command sent from my registered personal device. I opened the text interface, selected the substation gateway contact, and typed one single word in lowercase letters. Execute. Sending this signal would trigger 3 explosive high-voltage master fuses, instantly destroying $10,000 worth of electrical gear and permanently severing main power. But it would stop Spencer Cole from causing an electrical explosion that could take human lives. I pressed send 300 miles away, deep inside the dark electrical vault of Grayson Industrial Solutions. A heavy digital relay clicked shut, click. Then came a sound like a heavy cannon, firing inside a concrete bunker. Boom. 3 industrial master fuses exploded simultaneously, instantly severing 10,000 amperes of incoming electrical power before copper jumper bars could make contact. A massive plume of white smoke billowed out of substation ventilation louvers into the morning air. Emergency sodium lights went completely dark. Backup emergency power vanished. The factory was officially dead. An inert $70 million block of silent steel and concrete. My smartphone vibrated 2 seconds later. Oscar Diaz. Holy sweet mother of God, Dean. Oscar gasped. The whole master substation just blew. There is thick smoke pouring out of the power shed. Is everyone all right? The contractors came running out of the vault like their pants were on fire. Oscar reported, laughing. They are screaming that the main panel exploded. It did not explode, I said calmly, pouring coffee. The master emergency relay executed a hardware lockout. Spencer cannot hotwire a melted three-phase fuse. You guys are safe. Dean? Alistair Thorne's executive limousine just pulled through the main gate, Oscar whispered. He is staring at the smoke pouring out of the power building. Good, I replied smoothly. Tell him I send my warmest regards. The industrial disaster was officially over. Spencer Cole's digital transformation had collapsed into a pile of melted copper, ruined robotic arms, and over $275,000 in direct downtime losses. Now came the mandatory cleanup, and the cleanup required the master architect who built the foundation. My phone rang at 11 o'clock that morning. Corporate headquarters. I let it go to voicemail. It rang again at 11:05. Voicemail. At 11:10, a direct text message arrived from CEO Alistair Thorne. Dean, please call me immediately. Name your terms. I waited exactly 15 minutes before sending my reply. Mr. Thorne, I am officially retired from technical employment. However, I operate an independent automation consulting firm. My emergency advisory rate is $350 per hour with a guaranteed 6-month retainer. Furthermore, I require a written executive apology to floor technical staff, and I require Spencer Cole's executive office to be permanently converted into a break room for the maintenance crew. The reply arrived in less than 10 seconds. Agreed to all terms. How fast can you get here? I am 3 hours away, I typed back. Do not allow anyone to touch a single electrical switch until I arrive. I walked to my closet, pulled out my heavy leather work boots, brushed a speck of dust off the toe, and smiled. Showtime. I drove south down Interstate 75 at a relaxed speed, listening to a good jazz album. When I pulled my Ford pickup up to the main security gate at 2 o'clock that afternoon, Toby Miller saluted me from the guard booth as he manually cranked the gate open. Welcome back to the factory, Chief, Toby yelled out. I parked directly in front of the main entrance. CEO Alistair Thorne was standing on concrete steps alongside legal counsel. Standing off to the side, looking utterly ruined, was Spencer Cole. His corporate authority had been revoked. His suit was stained with soot, and 2 security guards were standing nearby to escort him off property. Dean, Alistair Thorne said, stepping forward with an extended hand. Mr. Thorne, I nodded politely, shaking his hand firmly.